Okay, so welcome all to this session, and thanks for spending some time with us to explore the challenges that we have ahead on the digitalization of the energy sector. We're going to have a workshop involving 5 different projects that are actually addressing this challenge at different levels, focusing in different aspects. I would put the focus in this introduction on the, not so much on the digitalization part of the workshop, but on the transition. My mother, and I suppose everyone outside of this room, when they hear the term of transition, energy transition, the first thing they think is about more renewables, green energy, less coal-based sources of energy. But at least the people in this room, we should all be aware that the energy transition is not just that. It's also a change of paradigm in the way the energy is distributed. We do not have any more just production in one side. We also have distributed production. We have new flexible elements as batteries, as electric vehicles that have an important impact in the way energy is handled. And all these new aspects can only be addressed with the support of ICT, with the support of technology. And I think that's the last part of the transition, not exclusively related to energy, but related to our daily activity. We are facing this last year, probably, for once, a truly disruptive technology event with the rise of AI. AI has been there for many, many years, but it seems that now, once and for all, it's having real impact on the daily life of everyone, and especially in the energy sector, in the daily life of the main stakeholders responsible on production, distribution, transmission, market operations, etc. These are aspects that, in my view, needs to be handled together: green transition, digital transition, energy transition, in order not to let anyone pass. I hope you enjoyed this session. We are going to explore all these aspects with projects that goes from more research and innovation point of view to projects that are much more pragmatic, focusing on deployment and really specific outcomes. And I would also like to finally welcome you all, not just to the session, but to the city. Hope you have also time to enjoy our wonderful city. Weather is not great, but the city is always ready to welcome you back whenever you want. Okay? So with no more delays, I give the floor to Patricia from the Connect that will introduce you. Okay.
Thank you. For bringing us already introduced a bit to this. That's a very complex transition that we are accompanying it from different sides of our profession, from the scientific part, the industrial part, and from the commission side, we are doing our best to accompany and support part via the policy. For sure, for many years, we are asking ourselves to where would we like this energy system to go, because this year was maybe the idea that we have a power plant and then I go to the energy and I trade a billion and I do not ask myself too many questions. But now for sure we are seeing that in the different times, we are seeing that we are having more about digitalization, and we are seeing also that more recently we are talking more about artificial intelligence and even generative AI, yes, and sometimes it is a bit of a clash of the words. There are the two words which are maybe one walking a bit fun, and this is a bit the energy one. The other one which always ran, and these are guys, because this is how they are used to go. Sometimes it's very difficult to align these two words. But we see that it is a big improvement in the last 8 years. And because the openness of all the two sectors towards each other, but we are still trying to find a system and to achieve a system which is which has all the adjectives which are there in that paper. I will not go through this slide. You know most of these things. I wanted only to reflect that in this common road that the two sectors have to decarbonize, decentralize, and also digitalize the energy system. There are also some achievements. Also, we have more renewables. We need to maintain them. Hopefully, one day we will arrive not to maintain them. I hope I will still live that moment. We see that electrification of transport is increasing. We see that also we are able to connect and control our heat pumps, and also it is an improvement with regard to what the energy consumption of the industrial sectors. It is the belief from the policymakers' side that we hope that this transformation is really becoming a reality. We need from digitalization, and this means that we have to be able to deploy digital backbone, or how we called it in the beginning of developing this concept, a digital spine of the new system, and also to empower this. For this year, all the colors changed, a little bit changed. It's fine. I don't know, maybe it's me. It was nice of the computer. It's not a problem. I hope it will not arrive anywhere. So, before you would have seen, I'm able here a bit the politics. Because for sure, before everything which was doing energy policy, energy implementation was looking towards the energy station. You see that now in the last years, at least the last year and also this year, there are coming a lot of acts which are digital acts and mostly touching artificial intelligence, but which are taking energy as one of the priority sectors. And we published at the end of the ETRA strategy, and the ETRA strategy, energy sector is a priority sector, and it is acknowledged the need of the development of AI models for energy and also the deployment of this digital backbone of the energy system. Also, this ETRA strategy, we work after this roadmap for strategy for the digitalization and the AI will also come forward and will be adopted. We work in tandem with it. We are trying to launch also the AI factories. And the AI factories, some of the AI factories are concentrated on energy. And some of you are coming from member states where these AI factories are located, and which have energy interest. I mean, do not manage to remember what the oil are kind of energy, but for the green policy, that it is an AI factory in the green, which has energy as a sector of people. I think it's Germany also, but I do not know exactly by part and different. So the factories offer the possibility to use to the scientists to go and to train the enemy. And then the factories will have the possibility in the very near future for launching the data labs. And it is also a thinking to have data labs for the future. So this is something to signal. Then the data union is something also very recent, where we are talking about the governance of the data, the governance of the data spacing, without dedicating naturally the sectorial approach, but it is a global approach that is again for the sectorial data spacing and for the mobility, which have many elements to interconnect. We have to respect the same rules. And we have to enable that the data sharing is something that provides the possibility of services. And then the last, which is still in the making, is the cloud and AI development. Where for sure we are going to, there will be key proposals for the scale up of cloud and data centers in Europe, for sure, with a condition of respecting sustainability and also ensuring safety. What is the thinking of the digital backbone? Some of you, they learn about it when it is called the digital spine. In fact, it is currently an organization of Paul, which is open for applications, where the digital spine concept is still there. If you apply a strategy, the digital backbone, but to be the we do not want the proposal or the thinking is not to replace anything. It's to do ensure a digital orchestration of assets. So meaning that it's not any intention to propose a system. It is not to have one platform doing everything. It is the idea to ensure that all these energy assets are interconnected. They can communicate between themselves. They can benefit of the exchange of data. So this is a vision which is articulated policy-wise in the climate strategy, and this is also a vision which we hope to get also from you as an R&I dimension within this call, which then will be continuing in 2027 with a successive call again in Horizon. Now, many of you here, and I only put it because I think it's also to recognize the merits of many of you who are part of this consortium, because in the work of the digital spine of digital platform is ongoing. There are projects which are belonging to different programs, the Horizon Europe, the digital program, and also the CERF Digital, which are contributing to this. And what we would like, because many of you are part of several projects, it will be that to encourage you to communicate within yourselves and to really arrive at the end with this concept. We know that it is again sometimes a clash between the acceptance of the energy community of the digital solution proposed by the right companies, but we see that it is a lot of compromise that was found, and we also see that there are many use cases which are currently not completely implemented, but piloted in several member states, quite an impressive number of member states. And so we consider that this digital backbone has all the capacity, let's say, to continue to evolve and also to become something that will become European. The data spaces are not exactly there, but are closely there. We have this INSIEME project, which is working on deploying the solutions which were developed by many of you in several data spaces projects. We have the part of the CERF Digital with BEGONIA, which had many interesting use cases, which again are piloted. And with this, accompanied also by the work on the governance of the data space, which is done, proposed solutions are proposed by the project, but then it is a discussion at the level of the member states and the level of the European associations and the industry representatives in the smart energy expert group. We do hope that by the end of this year, we will arrive to have a clear idea of what this governance should be, considering that we need also the agreement of all the stakeholders around the world. So this is everything that I wanted to share with you. It is clear that for everything, for all of this, we need data. We need high quality data. Please keep in mind that you will have the possibility to train your AI models for energy at the level of AI factory. Please reflect on these energy data labs because they will be innovative and they will present a very good scale. And also, please keep in mind that we are at a moment where we really need to think and to achieve a data sovereignty. And we think that we have to learn to the extent back a bit to concentrate on Europe, that the solutions should be European to the extent possible. Okay. I'm very much looking forward to hear what the project will share with us. And thank you very much for having me here.
Thank you, Patricia. So now just following the agenda, we have the first
Just one comment. Some people in
the chat.
conference saying that it's a little very very low. So maybe you can put. Yeah. Try to
Yeah, there's yeah, okay. We can be more close to the microphone. So Alvaro, come and explain what the community is doing.
Okay, thanks. I will try to speak loud, just the people in the telco. If you don't hear me, I will try to emphasize the. Okay, perfect. So we are starting this round of presentations with the OPENTUNITY project. And just before going to the technical part, I will explain some administrative information. The first one is that it's a project that we started in January of 2023, and it is expected that ends at the end of this year in December. We have just passed the second version of the innovations, and we are starting the demonstration activities. So our focus for this year is to perform the demonstration activities, make the evaluation activities, and check the conclusions and the technologies that we have developed in order to check how we can go to the market. We are a consortium of 21 partners in which we have grid operators, technical developers, market players, and other kind of universities and research entities. And we are doing our activities with a budget of 12.8 million euros. Regarding the pilot sites, we are testing our technologies in 4 pilot sites in Spain, Switzerland, Slovenia, and Greece. And which is important to mention here is that they are not siloed, they are not independent pilot sites. Most of the technologies are being tested in all the 4 pilots at the same time in order to test the interoperability and the replication potential of all these technologies. And what are the technologies that we are developing? Well, since we are in a workshop of digital technologies for the energy transition, as you may assume, most of our developments are software technologies applied to all the parts of the energy sector, from low voltage up to high voltage. In just a few words, you can see the OPENTUNITY technologies as a digital environment in which all the partners, all the actors of the energy sector can be benefited, and with these technologies we optimize all the processes. We are developing in total 13 different innovations, and in order to facilitate understanding of all the technologies, we can divide them or cover them under the umbrella of under 4 different umbrellas. OpenFlex, which are the technologies aimed to increase the flexibility at prosumer side, being prosumers, understanding prosumers as small and medium prosumers. Also open grids, which are technologies for the DSOs and the TSOs. Also, we have open space, which is in essence a data space, which it is used to manage the data fluxes of some processes. And finally, operability, which are not directly software technologies, but are methodologies that are important for increasing the interoperability of the tools. And due to the time restrictions of the workshops, I will just focus on 1 technology of OpenFlex and 1 technology of openability. Regarding openability, OPENTUNITY has developed the so-called OPENTUNITY topology converter. To understanding the rationale of this of developing this, I have to give you some context. Every time that we are working in an innovation project with a small or medium DSOs, we have the problem of managing the topology of the grids. As you may know, the topology is the basis for every smart functionality that we are developing in this kind of research projects. So managing the topology in the right way is crucial for us, and also it is quite time consuming for the technicians. And normally in small and medium DSOs, the format and the way they have stored the topology is not easy to handle. And you can find a lot of different formats. You can find DSOs that have the topology in Excel files. The most advanced one, maybe they are using C. Maybe they are using another software. And the point of the topology converter is, as you may start imagining, is to check the topology of the DSO in one format and translate it in a new format, capturing all the relevant information in order to facilitate the integration of this topology in the different ADMS or in the different software technologies that we are developing. The final aim at the end is to convert everything to SIEM, which we think that should be at the end the standard for DSOs. And one important point here that I want to mention is that we made this open source. It is available on GitHub, and our final aim is to have it in the Linux Foundation in order to have an extra seal of excellence, let's say. And it's open to the community to keep improving it. And just to mention very briefly that in the second review of OPENTUNITY, the European Commission and the project officer and the reviewer especially highlighted the importance and the relevance of this development. For this reason, I also wanted to bring this to this workshop. And the second innovation that I want to bring is more related to ECLIPSE. I don't know how much do you know about the concept of NIL, but well, the acronym of NIL is non-intrusive load monitoring. What this means? With NIL, we can disaggregate the consumption of an individual household just with the measurements from the smart meters, and we are able to know which is the amount of energy consumed by the fridge, by the air conditioning, by the heater, or by whatever asset that they have. We can do this, as I said, in a non-intrusive manner, and of course in a low-cost manner, because it is not needed the installation of any extra sensor or any extra device for capturing all this information. We are doing this using artificial intelligence, and we are reaching good results. We have not started officially the demonstration activities, but at validation stage, at training stage, we have achieved F1 scores of up to 96% of accuracy. It is not exactly accuracy, but just to understand ourselves. And we are now hoping to check with us the final results in the demonstration activities. And this NIL module it is expected to be also integrated in the architecture that is being developed in ECLIPSE in order to transfer this knowledge and all these functionalities to the whole Europe. And just to finalize, I want to mention some key takeaways regarding the importance of OPENTUNITY to ETRA and maybe to further European projects. The first one is that the developments of OPENTUNITY, the ones that I showed, and the others that I could not show, it is important because they will be the basis for future grid-related projects and commercial actions of ETRA, especially the point of the of the topology converted. It is quite important for us for that reason. Also, we are aiming to have a pan-European impact at scientific, grid, and prosumer level. As you have seen, we have developed technology for different ranges of actors. And the final takeaway is that we are now in position to start applying cutting-edge AI features, and we are ready to leverage the Gen AI innovations, like the examples that has been explained before. And I think that this is everything from my side. Thank you, and if you have any question, maybe afterwards in the panel discussion we can discuss more. Thank you.
Alvaro. We move on with the ODEON project.
Okay, so I will be presenting the ODEON project, and my name is Moisés Antón. So I will just give a few words about the project, where are we standing now, some context so that you can know what we are doing in the project. And I will also try to make kind of a connection, a bridge with the ECLIPSE project. So first of all, I would like to put you in this first slide, which is the consortium that the ODEON project is having. We are quite of a large consortium. We are the coordinators, ETRA IT, but we have several partners across Europe from different, let's say, functionalities and roles that make this consortium of 35 partners a big one, but a really productive one as well. So just a few words about ODEON. We are coming out of this topic of Cluster 5 that aims to support the green and digital transformation of the energy ecosystem throughout piloting IoT, edge, cloud, and other platforms. So the work that we are doing there is aligned fully to this topic. As mentioned before, we are 35 partners from 13 different member states. And our demonstrations are going to take place in 5 pilot sites from 5 different countries. And we are actually in the middle of the project. This project started in January 2024, and it's lasting 48 months. So right now we are actually in the middle of the project. And the project will end December 2027. Also, I put you some figures about the budget and the funding we are managing in the project. And aligned to what I mentioned before about the topic, mostly what we are targeting in ODEON is this big question of how we can do this green and digital transition from the technical point of view. So, as you know, the main goal of this question or highlight is just to how we can evolve from a centralized fossil fuel environment to a system that is much more energy efficient and takes into consideration these different renewable energy systems that can operate with a high degree of flexibility, and also that at the end it's decentralized. So in order to do that, what ODEON actually focuses in these 3 different topics, just to make a much more clear transition towards the green and digital transition. And the first one is to take consideration of all the assets that at the end are part of the edge, right? All these assets that are not that centralized are in our households or are much more on the outskirts of the centralized system, so that we can have some controllability and some let's say, operational actions over them. The second of these topics or these solutions is to increase this data observability, is to facilitate all this coordination of data from these edge assets so that we can measure them, we can have information about them in a much more clear way. And in the third pillar, let's say, we have the need for coordination between the different energy stakeholders, not only from the market point of view, but also from the intelligence and data interoperability point of view, so that we can increase the network stability and resilience through this third pillar. So as a consequence, ODEON is actually focusing all its developments in 5 different innovations. The first one, and maybe it's the more targeting data-oriented one, is the Cloud Edge Data and Intelligence Service Platform that implements and likes to be compliant to the reference energy data spaces implementation all around the energy, let's say, environment. But that would work, and this actually is the basis for the 4 different innovations that we are also placing here. Another one is the catalog of AI artifacts. These are all these machine learning algorithms that, from the point of view of the development of the tools we are proposing and we are leading to the experimentation of them through this catalog of different targeted algorithms. And the 3, let's say, blocks that we focus our solutions are these 3 ones. We are developing energy services for distributed system operators, mostly targeted on the grid efficiency and management. But also we provide services for local energy communities, just with the target of the reduction of energy costs, and also to increase the autonomy of these communities in terms of renewable energy systems integrations, but also flexibility of the assets. And finally, we also provide some services for prosumers, just for letting them have the capability to make much more informed and transparent participation actions in the energy transition. So focusing mostly on the part of, as mentioned before, of the data space environment, I have put here this slide just to put you a few words about which is, let's say, what we scope with the different actors and environments with the energy, let's say, layout. So we start our journey from the IoT gateway, in which we can have all this data coming not only from the centralized resources, but also from the different assets of the edge, as I mentioned before. And let's say that for that, we have this near edge and edge environments where we can capture all this data from the different, let's say, environments. But this data, let's say that at the end, it's going to have this cloud infrastructure that we can have this data space, all this data that's flowing from the different environments. And we can, at the same time, make a focus on what is this data and how we can process it in a much, let's say, efficient way, so that we can avoid having metadata that at the end it's not worth processing. And sorry. Okay, and let's say that all this data is going to flow, all these innovations that I was mentioning before, these different applications for prosumers, from local energy communities and from distributed system operators, that at the end, they are based on this catalog of AI artifacts that it's a construction of all these algorithms that our consortium is building on. So that is the environment that we are proposing from the ODEON point of view of the architecture. And just to have a little few more focus on the part of the, let's say, the cloud data space, we are providing also a technical architecture that at the end, all this data that is being conducted from the edges, but also from the more centralized environments, is flowing through this data pipeline, these different data pipelines, and at the same time, that this data, we can give it this coherence, this information, this context throughout the semantic mapper. So we have different services also that at the end facilitates the data management. And at the end that we also are compliant with the different data privacy and anonymization, and also that we can give this data the sense of anonymization to be fed, as I mentioned before, to the different modules that we are developing in ODEON. So at the end, the journey that the data from ODEON is having through the project involves let's say the value chain of the data of the different energy stakeholders, since we do not only focus that our data is going to optimize the energy field, but also that we can give this a context of a market, let's say, context, but also that at the end, all the data that we process also with this intelligence layer, that at the end, the data that we capture, we can also give them this sense and this, let's say, value for the modules that we are developing. So as mentioned before, we are developing all our solutions. We have 10 different demo cases, but what we do actually is focus on the different pilot sites in each one of the demo cases regarding the characteristics and what is the most attractive value for the different pilot sites. So we do not test all our demo cases in all the 5 pilot sites, but we focus on them accordingly to the strengths of the different pilot sites. So we have actually wide geographically distributed pilot sites covering mostly local energy communities, both in Ireland and Spain. But we also are focusing on the grid aspects on other pilot sites, such as also Greece, but also Spain and France. And we also are targeting our solutions and our demonstration activities in mostly prosumers from Denmark, France, and also Greece. So I just put a few, let's say, details about the different pilot sites so that you can see the scope and the magnitude of them in our project. So in Ireland, we are targeting 80 customers from smart metering, but we are testing our solutions mostly in 70 different prosumers in the Aran Islands. They're quite a rural area, but we are targeting to demonstrate our solutions in these 70 households. And also we have different assets there, such as solar panels and EV chargers that feed these demo cases that I was mentioning before. Regarding the area on the Spanish demo site, we are also targeting a much more audience of customers regarding the data that smart metering can feed our project. Also, we are counting with a larger number of prosumers, but we are also all focusing on the electric grid and also with some EV functionalities of the EV chargers that we have there in this demonstration site. In Denmark, we are also targeting a large number of smart metering, but we also come with renewable energy systems such as solar panels and wind power. We are targeting our scope of prosumers in 20 of the available on the islands, but we also come with topology of the grid and also some EV chargers there. And finally, in France, we are also targeting a large number of customers, and we also come with different renewable energy assets that feed our pilot site. And we also come with EV chargers and also the measuring of the grid. And in Greece, also we are targeting more or less the same as the other. So in regards to actually, because at the end, the scope of ECLIPSE and ODEON is quite different, but trying to think of a connection on how we can, let's say, two projects be interacting, is that at the end, since ECLIPSE is building on this framework, this third that is targeting for let's say the services for the citizen energy transition, let's say in a much more practical way. ODEON at the end is like to say the highway of how we can make this digital, let's say, data processing in a much more efficient way as well, so that what actually was going to be visible for the prosumers can have a solid background in data processing and data, let's say, management. So while ECLIPSE creates this environment for energy service application, let's say that ODEON provides how behind that application we can have a technical backbone for these federated data spaces that make at the end the vision of ECLIPSE interoperable and secure and gather all this data in a correct way. So that's all from my side. And if you have any questions, maybe we can then wait for the session afterwards. Thank you.
Thank you, Moisés. I didn't mention it before, but indeed we are keeping all the questions for the panel at the end of the session. So we continue now with the BEGONIA project, Razgar.
I am Razgar from Technical University of Denmark, the coordinator of BEGONIA. And I must warn you that my presentation is slightly different than what you heard because we don't have pilot sites. It's I'll take you through the journey of BEGONIA, where we are and how it connects to maybe what you do in ECLIPSE. And I should thank the organizer for inviting us as well. Thank you. So in a nutshell, this is a CSA project and something that is also quite different in BEGONIA. We are only 7 partners. It makes it extremely efficient and good for collaborations. And it's super good because anytime I need anything, I have the WhatsApp of my colleague. I just pass them and I don't need to send an email. So this is really good. And I can recommend if you are planning a writing application, keep it small. I'm also in another one with 39. Anyways, the project started 2024 and we are going to end in end of June. So in nutshell, the whole, you saw that if you remember, there was one slide from Patricia where she showed the timeline and where everything goes into digital spine. In BEGONIA, what our aim was to build operational digital platform. Now, sorry, Patricia, I know that the Commission is quite keen on coming up every second year with the new terms. And some years ago, it was operational digital platform. And what it was these are the digital systems, both physical and virtual, that you need to have in order to be able to serve some use cases. And you say, well, what are the use cases? The use cases are almost everything that we hear in the energy sector. Some of the problem may be with aggregators, so I'll give you some examples with the electric vehicles. And the idea was, what if we, instead of looking at the whole energy sector, if we just look at specific use cases, what sort of digital infrastructure do you need? Because so often we talk about the algorithm, but not so much about the digital side itself. And that was our mission in BEGONIA. So we were tasked to come up with at least research the area, the scope, the community, and come up, first identify the use cases. And we came up with a list of 14 use cases, extensive one, detailed, both from the community, what the project had already discussed, but also to see what is relevant for our cause. And then we went through some shortlisting based on different criteria, because since this is a CERF call, it is important that these use cases are also cross-border. So it's not just for one country. So we looked at the national project, cross-border project, and outermost as well, with different focus as well. Oh, yeah. So from energy to cross-sector, energy domain and mobility and some of those use cases. So we kind of split the 14 use cases in depending on domain and geography, and then we started shortlisting them based on some desk research, some one-to-ones with the commission, with the community, and we had quite a few selection criteria as well. But then we started evaluating them. We went to our stakeholders, and then we sort of published our shortlist. And then what happened at the end was that we came up with 10 use cases. So we made them smaller, but then it was quite obvious that a lot of these use cases, these energy use cases, they had so much overlap. And then what we did was to merge some of these cross-border use cases, meaning that also they became more complex, especially when you have to deploy the software or digital side, the digital systems. And at the end, this was our 6 use cases. So, for example, we had this AI-driven ODP for integration of electric vehicles, electric trucks, RES and grid. This was one. And then all the way to digital platform for drone-based inspections in linear infrastructure. So quite broad. But then our mission was that right from the start, that at each stage of the project, at the end, we need to come up with 3 use cases and come up with 3 prototypes, digital prototypes. So then we did another shortlisting, this time more expensive, based on sort of cost-benefit analysis. So we looked at each use case. What does it mean in terms of monetary value? So how much would it cost if you have to build such a system? What would be the benefits? And all the questions that you see here, all the things. So, for example, what we try to do for each use case, and this was a lot of work. I mean, I'm just trying to rush through there a bit, but to map the smart meter, the IoT sensors with different functions that we were looking into. And when we did some of the analysis, for example, for just one of the use cases, we came up with numbers like almost 2 billion euros in saving and also benefits for that you can gain. And again, these are the sort of numbers that, of course, the Commission likes to see, and we could also back it up with evidence, right? But this is an extensive work. It was only for the use cases. So when we looked at these use cases, we said, do they make sense financially? And how about in terms of technology? Can you have them? But more importantly, what we realized is with a lot of these systems, it's actually not the software itself, it's the regulation and policy. Because if you come from the software world, from computer science world, there is almost a solution for everything. And when I came yesterday from Denmark, I didn't need to worry about my mobile phone. I just, it connected to roaming services. I didn't know what the protocol, but I didn't need to worry about any of that. So my point is, it's exactly the same when it comes when we are building systems for the energy. What differentiates the energy sector is some of the local policies and some of the restrictions that we have, because a lot of times you are not allowed, even we are all within the EU, to share some of the critical data among the member states. Now imagine this scenario. If I have an aggregator in Spain, in Valencia, and I live in Denmark, I just want to buy my electricity from this Valencian electricity trader because it's cheaper. Why shouldn't I be allowed to do it? I mean, we talk about a free market, right? But if you come up with there is already a software solution, but it's the regulation that doesn't allow us. So sometimes I think in terms of digital, maybe we are a bit ahead of the policy, and there is a bit of lag here. And of course, this is just some of our findings. In terms of economic feasibility, we also did that, and all this information is available in some of our deliverables. In terms of technical feasibility, we ranked, as I said, all the use cases based on technology readiness, integration, infrastructure, availability, interoperability, scalability. So nothing new here if you come from the digital world, right? But I think it's important to know, for example, when you look at the use cases, where are we with the technology? Sometimes maybe you want too much from our sector or too little in some places. Regulatory, I think I don't need to mention that I've already said. But at the end, all this was just to tell you that we came up with these 3 use cases that we had to come up with the proof of concept. And the 3 main use cases were AI-driven ODP for integration of electric vehicles and electric transports and grid, electricity consumer-centric ODP and digitalization of data centers. And when we started Begonia, data centers were not as a hot topic as now because of the AI. And we are so pleased that we thought about it, and even then, when the AI boom was just at the beginning, we saw it as a big challenge and a big sort of one of the areas that could put a lot of constraint on the network, and it's part of our shortlisted use cases. So, in terms of the infrastructure itself, so what we try to do now is, for example, with ECLIPSE, if this, as I said, in Begonia, we only talk about digital and infrastructure. We don't look at the services. In fact, our aim is, so in our proof of concept, what we try to do is to get services from third parties. So this could be maybe a service from ECLIPSE or another company, so anyone, and see if they could be tried and tested in these environments. So meaning, our focus is solely on, can we put this setup independent of, so that we are not locked in only with Microsoft or Google solution, independently. That if someone has a service like forecasting service or aggregations or whatever, let's say energy management system, can you hook in and provide your service to another entity somewhere in the system? And this has been most of our effort. So right now, what we have is at least for 2 use cases, we buy services from third parties. We have the infrastructure. It's very, very basic one because it's a lot of work. But at least we can demonstrate that you are able to come up with the digital spine that Patricia was mentioning without being logged into a solution. And also without worrying about, because if we get a forecast service from a third party, that should be a black box. It doesn't really matter. As long as we all follow the same principles, same standards, the data spaces, interoperabilities, means, all those, then we are fine. But building the whole setup, this, I think for us, especially now with the AI, this would take a lot of effort. I think mostly effort not in terms of implementation, but coming up to the same understanding. I think I'll stop here and.
Don't have time. You want to explain more?
Yes, but yeah, I think I'll leave some for the class. But thank you so much. I'm sorry for rushing it through because the nature of the project is slightly different. But thanks a lot.
Good to see here. Hello, everyone. I think all of you all know me already. I'm Lola from ETRA. I'm the project coordinator for ECLIPSE Digital Europe program project. Most of you already know, so I will go into the focus and give some time for the demonstration of the energy app. Why ECLIPSE project is needed? We identified, as you know, the European Commission is promoting the acceleration of the energy transition in order to promote a more resilient, more sustainable, more fair economy in Europe. So, by means of digital technologies, but also the use of the energy, we are promoting a common European reference framework for the energy apps. After some analysis, one of it promoted by the European Commission, coordinated by ETRA, the analysis at the end reflected that almost all operators, CSOs, TSOs, also aggregators, retailers, other type of even third parties providing energy services had their energy application. At the end, each one was completely different. Some of them were similar, but at the end, they use different type of data platform, different type of formats. So at the end, this was a kind of a mess. And in response of this, what the ECLIPSE is promoting, and the ECLIPSE is accomplished for the time being, is a common European reference framework, exactly for this, with the guidelines for all the promoters of the energy savings applications in order to develop. It can be from scratch, or even also the existing energy applications to be integrated in order to enable a more consistent and interoperable solutions all around Europe. The idea is to provide services or benefits not only for the final consumer, but then it's the final customer of these applications in order to reduce energy consumption and energy billing, which is at the end, honestly, what all the domestic consumers want, but also by means of this application, by means of the potential flexibility that is provided by these apps. Also, the benefits are coming to the rest of the stakeholders, operators, in order to provide flexibility on the grid, also retailers, in order to provide additional service to the customers, etc. So, ECLIPSE at a glance, for the ones that are not so involved, is Digital Euro Program project, coordinated by ETRA with a consortium of 22 partners. We are not so lucky as Razgar, coordinated only 7 partners. Here, the main focus is demonstrations, so we had to involve at least 50 pilot sites. That's why the big number of the consortium of the partners. The total budget is 9.8 million euros with a funding of 4.9, and the duration and the most challenging is that it's only 24 months. So it's 2 stages, but it's honestly almost everything happening at the same time. We have just finished the first period. We have already the solution, and we are now finalizing with the deployment, with the demonstration activities, as starting with the exploration activities and the impact assessment. Yeah, very briefly, the idea of the consortium. As you can see here, we have every type of stakeholders of the energy value chain, from R&D entities to the operators, DSOs, but also TSOs, energy service providers, mainly aggregators, and also other energy associations that are able to promote the application somewhere. Here the consortium picture. Here some idea of the use cases we are promoting. This is something that we have been working during this period. The good thing in order to having the demonstration in 15 pilot sites around Europe is that we are demonstrating, or we are promoting the replicability of the Common European Framework. At the end, it's the main objective of the project is promoting this providing this Common European Framework, hopefully in an open way, in order to be used, in order to be used by any type of energy app developers, any other type of stakeholders that are interested in promoting that kind of application for the users, for the consumers. And hopefully something that will be our intention is going beyond the project, promoting something to be discussed or to be analyzed in this period, in the way how to continue with beyond the project, because it's not something that it will be on a paper that it will be just there and that's all. The idea is to make it open, to make it to publish and to be useful for any type of stakeholders in Europe. Here are some ideas of the architecture and the capital profiles for trial college.
Okay, so yes, one of the main objectives of the ECLIPSE project was to develop this CERF, Common European Reference Framework for Energy Apps. So the goal of the CERF is really to support existing and future energy applications to integrate into the smart grid ecosystem. So our goal here is really to focus on the interoperability and scalability of this architecture to support this integration. And we are very much focusing on high-material applications. With the goal in mind to have some kind of label, CERF label to validate the interoperability of these applications and their ability to be integrated. So this is the first version of the architecture, the current version of the CERF, that very much focuses on the energy app and how it is integrated within with the energy resources, with the energy grids and the energy markets. So complementary to this architecture, we have also developed interoperability profiles that kind of aim to bridge the gap between the architecture, which is quite generic and theoretical, and the actual practical implementation. So we have developed 3 interoperability profiles focusing on the main, the most critical interoperability aspects of the architecture. And the goal is to be able to integrate potentially more in the future, more interoperability profiles partners to be able to represent more use cases or more environments, and really to support these applications in practically implementing the interoperability aspects. So we apply a 5-layer structure to this interoperability profiles to include aspects of policy, behavior, semantic, syntactic, and transport interoperability to really have a complete interoperability structure for the integration of these apps. And in order to develop these interoperability profiles, we very much relied on our 15 pilots in order to have a review of what are the practical needs from the field. And we also prioritized the standards and framework we wanted to integrate into these profiles based on what their technical fit, whether they answer the need or not, but also based on their maturity and implementation feasibility to make sure that everything is ready for the applications to be able to integrate into the system.
Thank you, Dion. So as part of the ECLIPSE project, we are developing an energy mobile application for end users with the main objective of serving as an example on how technical partners can integrate the services that are being developed within the project, thanks to the CERF, in an end user application which can be used in the project and after it finishes also. So while developing it, we ended up with the conclusion that we needed 2 different versions. So here what you can see in this slide is, on the one hand, the version focused on the end users of DSOs that want to see personalized data. So what they would do here is register themselves, register their smart meter, and then they would be able to see these different functionalities that we will be showing in a moment. Also, as there are some partners in the consortium that don't have the technical capabilities of either integrating the CERF services in their application, or they don't have an end user application developed so far, we are testing these 2 versions in some of the pilots of the project. On the other hand, we have a version that is more aimed at people that are interested in knowing more general data, national power demand, generation, and so on. And this is also being tested in, for example, in pilots from Bulgaria and Cyprus. The names of the application are not definitive. They are subject to change before the project ends. Yes, but these are the versions we are working on right now. We are having some tests and refining the application, and we expect to have a final version by the following months. So yeah, I'm sorry for the people that were present yesterday if we are repeating some things. But for today, instead of playing a video that was already pre-recorded and going through the different functionalities of the application, we decided to bring a mobile phone with the application installed so that we can go through some of these functionalities in a brief demo that I will be showing right now. So what you can see right now is actually connected to a phone I brought today. So if during this morning any one of you is interested in testing the application, going through the different functionalities and so on, please don't hesitate to ask us during the morning, and we can share the phone with you. So first of all, let's go through some of the aspects of the version for DSO end users. Here, for instance, we registered 2 different supply points. So in case you wanted to add a new one, you just go at the bottom here to add new point. And by inputting some basic information, such as the name, location, and the ID of the supply point, you would be registering a new one, which I won't do now as we already have 2 of them here. Then once it's registered, it would appear here, and you could go into view details and add some appliances. This is not mandatory, but it's some added value. As we can see later on, the application also provides some information that is based on the disaggregation of appliances using the NILM my colleague Alvaro explained before. So we could, for example, here add an extra appliance. We already registered 3 of them, but we could add, for example, a kettle and write, this is my kettle. Yeah, the model I don't know. And yeah, some basic description. And after it's added, we can see it here, and we will be able to see later how the NILM is disaggregating the total consumption into these 4 appliances. So moving on to the next menu, we have monitoring, where we are able to see the consumption of the supply meter. We can go inside and see for each hour the total consumption. We can change either for today, the consumption for this week, for this month, etc. If we go back, it's more or less the same for the power consumed. So we can see the daily power, the values for maximum, average, and minimum. And we can also change from daily to weekly to monthly power. Going to the bottom, we can see here the disaggregation. In this case, we are already using the algorithm developed by ETRA, which is called NILM. So what it does is takes the total consumption from this specific meter and disaggregates it into the different appliances. As you can see, for example, dishwasher is consuming 39% of the total value, fridge 17%, and so on. And then we also have a graph showing the price for the day and also for the week and for the month. Moving to the flexibility menu, we have here some options such as selecting a threshold value that if the consumption surpasses this threshold, the user will be notified with a recommendation saying you have surpassed the threshold, you could reduce in this way or in this other way your consumption. Then we also have some extra functionalities, such as sending reports in case of appliance malfunctioning or in case of having some doubts. And finally, in the tips menu, we have general tips, which are general for all the users of DSO. For instance, this will be decided by that DSO depending on what aspects they think are interesting for their end users. And then we have some personalized tips, which will take into account all the values that are obtained from the smart meter and give recommendations based on those data. And finally, here at the top, we have a notification menu where all the notifications that are received, either recommendations or service new information, will be also received by the user here. Now moving to the version that shows more generic data to users from TSOs, we have here at the top the national demand, which can be also from the last 3 days and also for the whole week. We also have the power generation divided by the different sources. And if we go to the grid status, we can see the map of that specific country, and divided by zones, the end user will be able to see what is the current status of each of the zones. So for example, a green zone shows the level is normal, operating with normal parameters, and there's no problem in this case. But for example, there could be a zone in orange or even in red showing an alert or an emergency. The user would be able to see what this alert is about and what's the expected end time of that emergency or alert. And finally, for tips, we also have some general tips for all the users, and also some tips that can be filtered depending on the preferences of each one. If they want to see information regarding EVs, specific recommendations for their location, and so on. So if we uncheck, for example, these 2 options, they won't be able to see the specific recommendations here. And also some notifications that are shown here for the user. So yeah, this is more or less a quick walkthrough for the whole application. So in case you are interested, you are free to take the phone for some minutes during this morning and check it later. So going back to the presentation.
Yeah.
Mi parte no.
Okay. Thank you, Alejandra and you for this. Yeah, just as a summary of the presentation, the app we have just shown you is one of the examples. One of the that have been developed as part of the project. However, the point is that the CERF should be compliant. I mean, the applications, all type of applications can be developed based on CERF. Also, the existing ones could be adapted to the CERF. This doesn't mean that it's not. You don't need to have the specific application from developed from ETRA, but any other type of application could be compliant with this. And I mean, we are trying to make it in a very smooth way in order to make a kind of standard of the common platform where everyone will be based in order to develop the application. So yeah, comments and questions can be later on in the panel. Thank you very much.
Hello everybody, my name is Shievam and I belong to University of Applied Sciences of Austria, which is coordinating this wonderful project INSIEME. I am pretty sure everyone, or most of you have heard about this project because this is so strategically to create this common European energy data space. And we're lucky to be a part of this and to coordinate this as well. So I think many of you might be familiar with this illustration. So there are different personal data spaces. There are some data sets which are of very high value. All these were already there, but there were also different data spaces up into the ecosystem. And then, luckily, the European Commission thought to bring in all those to combine best practices and to bring common data spaces for different sectors like health, agriculture, finance, mobility, green deal, energy, and so on. Out of this, we are talking about today the energy data space, so common European energy data space, and which also needs to have some basic principles to be considered. So, for example, it should be always driven by the stakeholders. So everyone should be involved. It should be more participatory. It should be by the sectoral governance. So there should be governance which is specific to the sector itself and not something which we develop which is not used by the sector. So it should be by the sector and for the sector. And there is a rich pool of data that is lying there. But to trigger the innovation, we need a European data space also. There are different components for the technical infrastructure of data spaces like edge infrastructure services, cloud infrastructure and services, high performing computing, AI on-demand platform, AI testing, and so on. When we talk about INSIEME itself, so we say INSIEME, as you know, is the word to come together. And that's how we say together towards the common European energy data space. The project started in April 2025. So we are relatively new in that sense. But we have a vision that the data space should be by the sector and for the sector. And that's the reason why we have 54 partners from different 15 member states. So that's a big one. But I see the positive side here because so we have 54 partners. Therefore, we have a lot of different perspectives coming into the pool. And the bigger pool of different perspectives ensures that what we are developing here is actually more relevant to the stakeholders and to the people who would actually use this. The overall budget is of 16 million, which out of which 8 million is co-funded by the Digital Euro program. And we would have 14 deployments in 16 plus European member states. As I mentioned earlier, INSIEME is together. So we bring togetherness here, but we are pretty sure that we always have to respect the European principles of subsidiarity. And what we are developing should be minimal invasive to the member states, and it should be a slim federation service. So things should not be destroyed, but rather they should be made interoperable. This is the key here. Yeah, this is the consortium map. So we are spread across Europe. So we have partners coming on from different diverse landscapes, political, economical, social, political, and so on. Most of them, or all of them are listed here. There are some additional associated partners as well. Then we have research and innovation partners amongst them, infrastructure operators, industry associations, new market actors, consulting services, and solution providers. So a wide pool of expertise coming into play here. The idea is to have also a common APIs to have different pillars of data streams to be fed into the active European customer. So this is what we also achieved in Project EDI, where different data streams, for example, data sharing infrastructure from the member states, in-house data source assets, publicly available data, and the data from the marketplace, which is refined and crowdsourced, could function together to provide services, for example, to energy consultant, energy communities, flexibility service providers, and so on. But this is just the idea here, what we are using, but it's not solely relied on a Project EDI, but we have luckily expertise from all the other most relevant national and EU initiatives. For example, EDSN, EnerShare, ECLIPSE, ENEDIS, DataDis, DataSeller, OmegaX, OneNet, EnergyNet, and so on. So we try to club their best practices, their lessons learned, and to replicate what is really required into the system here. We have 7 sectoral deployments. So the first one is energy efficiency and flexibility management. Here, it's very much related to what we are doing in CERF. We are learning a lot of things from Project ECLIPSE in that sense here, because these energy efficiency and flexibility management services are customer facing. And what we learned from CERF is how these applications should be designed, what are the best practices, and therefore the reference architectures for the energy efficiency and flexibility management are quite inspired by the works done in ECLIPSE. Here we also additionally foresee to have common digital interfaces for price. So for the energy suppliers, for the grid prices, so that it's easy for the end customers to understand what they are paying for and when they are paying for. Then the second sector is this collective self-consumption. This is really a faster growing economy right now, the energy communities. It's a hot topic. And I think we have somewhere around more than 7,000 energy communities in Austria. And the same goes on with other member states. There are so many energy communities. But usually there is a problem because one solution which is really innovative, it's difficult to replicate in other member states, because running an energy community the algorithm can be applicable to other member states, but the problem is the integration of this algorithm for data fetching or the data sources. And this is where INSIEME or the SEEDS, Common European Energy Data Space, can actually help. Then we are also talking about the grid flexibility services. There are the basic problem between the end users and the system operators is there is really a lack of communication between private energy producer. And therefore, what we need is this flexibility connection agreements. And this is what we are going to realize here in this sector. So the FCA's flexibility connection agreements would help to decarbonize the grid itself and also to have decongestion on the grid, because sometimes there are some PV installed on the roof, but the end users cannot feed in because of the network congestions there. And this is what we try to focus here. Also, we take into account the network code on demand response and other aspects. When we talk about the electromobility sector, this is about more of not just the residential electromobility sector, but also the heavy-duty trucks. This, by the way, this task is also led by Volvo and Renault. They are more focused on the heavy-duty trucks in that sense. Usually there is a problem because the charging point operators can always show what's the peak available energy for their charger is, but they cannot tell in most of the cases what would be the energy available when the actual vehicle goes for charging. So they cannot forecast this upfront. The reason is because they are not most of the times aware of the grid congestions that would be happening because there is a lack of communication again with the system operators and the charging point operators. This is what we try to solve here again with the electromobility sectoral coverage of INSIEME. Additionally, because in grid action plan, this is mandated that the system operators should publish their capacity maps, and we would or we are trying to make this machine readable. So it's automatically read by the system operators or by the service providers, so that they know upfront what is even before planning the charging point itself. They have more information and they can make more informed decisions digitally. Then also we have some other sectors, for example, renewable integration. In this, we are talking about more the larger scale power plants to help to avoid the grid curtailment, because in many cases there have been the power plants which have the capacity, so we actually waste the carbon-free or green energy because we cannot feed into the system because of the grid curtailments. And this is what we have in mind, to have more smart renewable integration. Then we are also taking care of networks and integration planning. This is about more AI applications and machine learning applications to plan the network itself. And it is a key aspect to plan the network itself, because as you all know, what we are planning here is it will go on for many years further. So the network does not change very often in in a scale of 1 or 2 years. It stays there for decades. And this is very important because also of the rising demand and also the changing structure of the energy landscape. Then we have sector integration where we are also taking care of different energy vectors. This is led by the Danish cluster DTU here to make sure that energy, gas, hydrogen, and other aspects can be very much interlinked, because in one aspect we have been talking about for the last few days on also in this workshop more about the digital silos, but there is also a need to destroy the energy silos. So between the relation between energy vectors, for example, electricity and gas is one of the key aspects. Yeah. So we are taking care of all these sectoral presentations or deployments. And when we talk about the relation between ECLIPSE and INSIEME, so I have this analogy where I see INSIEME as the pipelines, the infrastructure, and ECLIPSE as the faucet or the tap there. So the infrastructure provides this data space infrastructure that is interoperable, respects the data sovereignty of the member states and all the data owners. There is transparency, governance, standards, and APIs. And on the other hand, CERF and coming from ECLIPSE provides this user-facing application, so where the value is actually experienced by the end users. And the water in this analogy is the data flow. So this whole system together ensures that the data flows in a secure and interoperable way. So if the pipes do not work the same way with the same standards, it could be difficult in different member states to come together with the process. In short, I can say this ECLIPSE shows what works, and INSIEME makes sure that this can work everywhere by the help of standardizations, common APIs, and the common infrastructure we are developing. I think this is the strategy. This is the timeline where different projects from 2022 to 2025, like OneNet, EnerShare, EDI, DataSeller, Omega X, and Synergies, the sister projects of the data space cluster were running. We are happy that most of the partners from these projects have participated together in INSIEME to make sure that we do not miss on best results, and we also take care of what works and what does not work in this INSIEME project. So the project goes on from 25 to 28, the deployment and the final pilots of seeds, common European energy data space, and then in 2030, the operationalization of common European energy data space is planned. So thank you. That was it from my side. Thanks a lot.
Don't go. I kindly invite all the people presenting this morning to come to the stage. Good. So I don't know if there are questions in the audience or in the people connected. I don't have access to the chat. Okay, if not, on my own, just a couple of typical questions, but still relevant. I would go with interoperability and user experience. So just a couple of questions for a start. How do you actually achieve interoperability in your projects? I mean, we've seen projects that are actually targeting this as one of the main issues of innovation, but it's something that affects all of you. So what has been your approach? And the second one is pretty much related to what was discussed at the beginning of the session. How are you actually making sure that consumers, small companies, are not left behind, and then actually have the same level of access to the tools and to the solutions that are being included in the project. Who wants to take at least one of these two questions first?
Maybe I can take the interoperability one. So as ODEON, well, I guess as INSIEME is based on what has been built from data spaces. We've been struggling actually to look for the interoperability in sense of which is the connector that we can implement to our architecture that at the same time can be make the other solution as interoperable as possible. So what we are trying to do while we are now still in the development phase is to try to look for this connector to make our let's say data space interoperable with the rest of the other ones. So that's how we are kind of tackling this interoperability issue.
Nolan?
Yeah. Yeah, maybe that very quickly answering both of them regarding interoperability. But as our approach, also we also have a data space. Our main approach is always to focus on current standards, not reinventing the wheel, as I have shown in my slide regarding the topology converter. The idea is to try to promote SIEM as a standard for also DSOs, not only TSOs. And regarding your second question, so we can ensure that we don't leave anyone behind in the energy transitions. Well, we in OPENTUNITY we are doing this mainly at the technological level. As I mentioned, our technologies are addressed to small or medium DSOs that normally don't have access to a amount of resources or so many technical skills, and we are providing them technologies in order this amount of actors to be in the same place that maybe bigger actors, and also, for example, with the NIM, trying to provide low-cost technologies for the citizens, that no matter what is your level, so your socioeconomic level, you can be part of the energy transition.
If I can add, well, first of all, that there's only one place for ECLIPSE, but everyone, since most of you are partners of the project, especially the speakers, but not only you, please add whatever you would like. Regarding interoperability, what I said, ECLIPSE project solution, it exists. The reason is that we need interoperability. That's why it's the reason of the project, why we need ECLIPSE is due to the lack of interoperability we define that kind of energy applications. So that's what we are going to, or we are trying to promote the interoperability among the different solutions in Europe, and yeah, in order to promote the different types of OMS and different types of solutions.
So when it comes to INSIEME, I think what we are making sure is that the reference architectures which are being created are actually by the end user or the users of the sector itself. So this makes sure that what they actually need is being already considered into the reference architectures. But at the same time, we also have some strategies. For example, when we talk about the energy system or data being shared into the energy ecosystem, sometimes it's just SIM, which is more required in the upper layers, but sometimes it's CERF, which is required in the lower layers, for example. And what we do is we do not post only one standard to be available for the users of the data space itself, but rather we consider what are the new standards which should be there. So we do not just support SIM, but rather support SIM, CERF, and other ontologies. So we are creating, for example, these wrappers of the ontologies which can be used to get the data in format which we need. And when we talk about how to make sure that the consumers are not left behind, so we believe that three main aspects or three main pillars are there. For example, what consumers need is transparency. of why or what their data is being used for, control to control the data flow and access, and then the actual benefits to what they need. It could be tangible or non-tangible. So tangible means, for example, financial benefits, or non-tangible means could be decarbonization or altruism in that sense. If these three aspects are there, the solution is more probable to take the customers on it. And we do this by having dedicated consent management flows. We have dedicated mechanisms to have the consent where the permission is specifically given for each type of data access, and data does not flow without the permission out of the scope of the customer. And also the data is stored with the customers as far as possible and not at the central level.
Maybe from Begonia, we share more or less the same when it comes to interoperability, not to reinvent the wheels. When it comes to data, obviously, our aim is to use data spaces, and this is one of the main connectors. But then to the software itself, we focus, of course, a lot on open source data, open source solution. For example, when you have to work in different systems, Kubernetes, Kafka when it comes to IoT, and then authentication. So in Denmark, we have this thing called ID that for the end users not to be left out. They can just sign into, so we have this public authentication service that every citizen has access to, and then using those systems, we are able to share the data. But I must also say, in our project, we don't go to the consumer level. So our consumers are third-party service providers.
Okay, as I mean, they were already in the screen, but as natural follow-up questions of these two first explanation you provided, you have been mentioning a standard, not reinventing the wheel, letting the actually end users to participate in the architecture in order to ensure that it's going to be adopted. All these things are critical aspects also for replicability and the scalability of the solutions, and also critical in the sense of okay, by the end of the day, the solutions need to be self-sustained, which means that someone will have to pay for them, which means that there is a business behind and a need for exploitation. Not just considering that some of us are coming from industry, and then our owners demand to make some profit out of the business. So I will be straight. How do you plan to exploit the results? And then, following your previous explanations on interoperability, what are the challenges, the big problems that you encounter when it comes to escalate and replicate the solutions we have? We've seen that we have projects that actually are targeting many different pilots from many different countries to actually overcome such problems. But the truth is that when the time comes to actually deploy the solutions, regulations, the maturity of the markets are completely different. So please, who wants to start?
We can start. Yeah, so regarding the main barriers of scaling or applicable capability of in the case of CERF, it has been mentioned already the user experience. I mean, the user in this case, finally, the domestic consumer needs to be convinced that this for something. If you are using an app, you are taking your time for this, you need to find the real benefits. And in this case, honestly, normally it should be a financial benefits for them. So it should be very clear, very user-friendly, very concise, and very easy to use by every type of consumers. We are not only thinking of people that are familiar with digital solutions, young people or people that are in the area of energy, but every type of consumer should be to be able to use it in a friendly way, this kind of energy application. Other things that could be a barrier for people using it is the data privacy. The data coming from energy domain, it's private. It should be protected. It should be convince the user that this data is not coming anywhere, that it's going to be protected and they're going to be used only for their own concern. And finally, what you mentioned about the other patents and barriers, policies, of course, regulation should be the side of this, to be promoted at a European level, as we say, in order to facilitate the promotion and even the obligation from the Commission in order to every type of stakeholders on the industry to provide their data in a secure way, of course, but in order to have a common repository in a data space, or there is already data for any type of everyday data sources. And just to finalize, in order to exploit the third, again, it is also very related with the policies. This is something very European level. A common reference framework should be promoted. Once the project is finished, it should be promoted in one way or another. But it should be go beyond that with the support of we're talking about foundations, about funding from the European Commission. It's something to be designed, but it should be possible to be exploitable with the support of an entity that will go beyond the project.
You may disagree between each other, or even if someone disagrees,
To be a discussion, not be a speech.
Actually, in my view, acknowledging and agreeing with all what Lola has said, I tend to judge our results always from the hardest point of view. And whenever we use the card or the excuse of policy and regulation, I always try to think that the responsibility of demonstrating how useful our solutions are, and that therefore policy and regulation must change, is on our side. So it's up to us to do something as brilliant and as necessary that, of course, all end users, consumers, and operators, all the stakeholders come and ask for our solutions, and then policy follows, and the solution is probably accepted, which is obviously something really difficult.
That's maybe I can continue just giving the view of OPENTUNITY and the innovations that I saw before regarding how to exploit NIM and ensure replicability. Well, we have two ways of doing it. The first one is together with the energy app zone by my colleague, which is relying on the ECLIPSE. So our one way of exploiting the NIM is just together with the ECLIPSE, and the other way is as a standalone module to be sold or to be transferred to other type of energy service companies or energy retailers that they already have the power and the clients in order to spread the benefits of this NIM. And in the second point, that is the one that it is also quite interesting for OPENTUNITY and for ETRA. Regarding the topology converter, well, as I mentioned, it is open source, so it is available to every person or every company in order to make use of it. And it is especially interested for ETRA because it is an enabler. I mean, at commercial level, we have an advanced distribution management system, and when we try to install or deploy our system in a smaller mailing DSO, we spend a lot of resources and time on working with the topology. With this topology converter, we reduce these activities, so we can increase the profitability. It is more appealing to us, and also because when going to new projects, for example, if we have a project regarding the digital spine, we are sure that we will be able to work with the topology of the pilot sites without such problem, and not focusing so much on handling and fighting against the topology of the DSO, but we will be more focused on working on the actual functionalities and the actual capabilities of the technologies to be developed in that project.
Yeah, maybe some perspective from INSIEME in that sense. So when we talk about the replicability and stability, so what we are taught in general, the exploitation plans. So the idea is that we do not do something now and find the exploitation plans later, but rather to involve all the or most of the partners who really want to use the system right. So, for example, when we talk about the energy communities, we have already some partners who are having their own energy communities right now, and they are participating upfront now. So, from the very scratch to know what they would be using in the coming months or years, and therefore the development should be in a way that it's truly inclusive and participatory. So I think exploitation, although in many projects it's towards the end of the project, INSIEME is relatively in the start, but the exploitation is already in place in that sense, because the partners with or the application providers are already participating in the system, what we are building now, and we are building it together with them, not just building on other. And for when we talk about the policy perspective, so the idea is also that some of the participants of the project are participating in different forums, the forums which are more important for policy making. To name a few, for example, data for energy and other forums there. So not just to learn what is going to be there and to prepare ourselves, but rather to also feed the knowledge what we have already gained from other projects and other perspectives within the consortium. So that's why we are kind of being proactive in both the senses.
Maybe from BEGONIA it's slightly different because we never have this target of exploitation as X number of solution services, but more maybe something that I didn't share at the beginning was there was a plan by the Commission to have a follow-up call of 20 million euro that was cancelled. And then we sort of changed our course where we decided to share our knowledge, but mostly now that we work on the proof of the concept to share some of, because now we are working on creating connected data space connected, for example, for IIT, but it's not available in the community. To share it with the community as open source is one of the outcomes. But what we see now in terms of the big picture, some of the ideas are already ongoing because whether it's with BEGONIA without the digital spine is sort of continuation of the same mindset. Right? So whoever does those projects at the end will need to refer to some of the findings from ECLIPSE, BEGONIA, and INSIEME, because these are the foundations.
Yeah, to add up, I want to maybe just say about how we are just making this replicable and scalability approach in ODEON. Is that also we are celebrating living labs within our project that we kind of take also consideration from outsiders of the project in these different living labs so that we can align our solutions. Let's say that we invite end users, distributed system operators to these meetings so that we can gather all this information, all this data, so that we make sure that we are targeting our solution in a scalable and replicable manner. So that's the approach we are taking to that point.
Okay, thank you all for clarifying these questions. A question from the audience. Great, please.
Hi, I'm Mateo from Foreign Minister Research Center in Portugal. I wanted to elaborate a bit on the example that was given by Razgar. You mentioned that when you travel, when we all travel, you go to a different country and then everything connects in your mobile, the internet works, something like that. This example, like, it's, I think, the result of a conversation that involved many common agreements, many common things, you know, between countries, and so many legislation from the Commission this year. And you mentioned that probably in the energy sector we should reach a point that is very similar, you know. But there's a thing that it's quite difficult because I think here, I don't know, I'm not an expert in telecommunications, but in the energy, it involves many things like the operator, the market operator, you know, and many things that I don't know how, in what extent we can reach such level of interoperability that you are saying, okay, someone in France can use something else, a research that is in Spain. So yeah, my question is like, how all of these things like relate the example to each other, also the opinion of the rest of the panel. Do you think like really such integration can be reached? Because we are clients of big mobile, so for us it's completely independent. But now we're not the client of the energy, we are part of the stakeholders of the energy. Who will be doing all of these things? We need to talk with the operators, we need to make many common agreements, many things in common. Yeah, can you give your opinion on this?
I mean, I'll start from the question. I genuinely believe that one day we will achieve that. So that is clear. And I'll give you another example. I think this is more change of the mindset, right? I'll give you another example from the finance sector. When you came here and you used your visa card, you didn't care. Right? Yes. And it is way more sensitive as well. I mean, the energy sector is sensitive, but hey, everyone cares about the money. And we managed to do that in the finance sector. So it's not, I think in the energy sector, we for many years, we have this silo mindset. If we get rid of that, there are many solutions. I don't think we are out of solutions, but we just need to think together and slowly we get there. Maybe we don't need to have everything next year. But I think we are moving in the right path, at least from the policy, from the course, and where we are heading. It's step by step, but
I mean, of course, that the support or the policy, the policymakers at the European level in this case should be the ones that are that put the basis. But technically, as I mentioned, we are in a good way, and so I mean, with the programs, the goal that the Commission is opening, it seems that I mean, it's the objective. So let's hope for the best. And as you say, the telecommunications and financial sectors make it. So possible.
Maybe something here. So what I also learned from, I cannot remember it correctly, but there's a concept in sociology where they say that the technological advancements are more dynamic. They happen in very short duration of time. And then some things then proceed to the next societal change, the next strata, and then the third strata goes to the policy change. So I think, yes, there is probably not a policy right now to support something like this in energy domain, but when we talk about the societal change, this is, or the technological change, this is already something what we have in our mindsets now in the project horizons and so on. So I think there are some technological advancements which can support some things like this in this direction, which would, I see, trigger something in the societal aspects where people will start demanding something like this, and then the policy will adapt to it based on the demands of the society. What my ideas.
I have another question about governance of the aspect. So you said that it should be a user-driven, so I understand this principle, and I think it's a good principle, but I think maybe we should have the possibility to take into account some specificity. For example, in the INSIEME project, I think that it's just an example. One example, one of the use cases is to develop a European interface for balancing processes. So balancing processes It's a very critical processes and operational for the TSO. It's a very concrete impact on the grid safety, security. So for me, as a TSO, it's really difficult to imagine that the European interface for balancing is not designed by the TSO. And I think if it's not the case, I am not sure that there will be a strong, maybe more, but I am not sure that there will be a strong willingness of the TSO to connect to this European interface.
Yeah.
So I understand the principle of the agreement, but I think we should also take into account some specific constraints.
I think that's really true because so when I also mentioned the users, I did not mean only the end users, but rather in that sense, the TSO is the user of the data space. So the governance should definitely take care of the users and not just the end users, but rather, for example, TSO and so on. I hope you.
Yeah, I think this is something that it's we were commenting it also even before starting that we're in this intersection between the ICT domain and the energy domain, and it is important that the end user, not talking about consumers or consumer end users, I mean the TSO, DSO, aggregator, retailers, all the stakeholders in the energy value chain are the ones that should be driven in that sense, the definition, because it's the only way to that later on is actually adopted. We've seen projects where let's say the time was proposed by the ICT experts, proposing really great things that by the end of the day were really hard to actually deploy and implement. And at the same time, I fully agree that more than a challenge with regards to technology, even policy, is a challenge in our mindset. These silos have been there forever, and they also affect whenever you go with a new solution to one of the end users. Doesn't matter in which level of the hierarchy. The first reaction is, I don't need it. The system is already working. What's for? And yeah, again, it's our responsibility to prove that the solution improves in many different ways, economically, societally, in many different ways, improves what they have. But yeah, a certain change in our mindsets is needed. Otherwise, the first reaction is, there is light. The system is working. No problem. No problem until we reach one day in Easter. Then Spain goes to black. So there are still things that can be improved. Please.
Yeah, so I wanted to build up on the own that first made before and I feel the reactions there. And of course, then I'm going to ask a question about the Razgar because I'm still from BEGONIA, so I cannot know the answer already. But my point is that I think that probably the main difference between the different sectors is that in the energy sector, it's a physical component. That is the main challenge. And of course, so there is a part that is inherently in a silo because so that we have to solve from a different point of view, like interconnecting more, but then we have also to build more infrastructure problems, right? So but there is a part that probably very different to solve, but it's true that there are a lot of services that we could easily just provide to all in the whole Europe. And I kind of have like the feeling that, and from our policy background, I totally agree with that there is a problem in regulation. But my question is then, again, not to BEGONIA, but to the others. Will you see that the problem is more at the European level or than the national? Because I think that this is at the national level, way more than the European. Of course, yeah, we have to progress because things change and we have to adapt and you know that this is actually happening. But I think that the bottleneck sometimes is at the national level. In BEGONIA, one of our main challenges was that our ODPs needed to be, all of them, cross-border, which is great. The point is that, of course, it's very hard today
to have a solution that can actually work cross-border, not for technical reasons, but for policy reasons, and not because the European policy is not there, it's the national policy that is not there. And in fact, my question to all of you is that, did you see this in your projects? Is this kind of the same, that you cannot like implement it, but because you are perfectly in line with European regulation, but at the national level, you are not?
I'm not expert on regulations or policies, but yeah, I agree that the national, I mean, they don't care about the rest of the countries. That's why, in my opinion, it should be the Commission and as a high level policymaker or whatever, in order to push the regulations and the policies in order to oblige one way or another. For instance, to be open to the countries. I think the very example of the communication with the roaming. I don't think the countries will say, okay, I would like to give the roaming for the partners for the people that are coming, but the Commission is there in order to say, okay, we should be compatible with everyone. You should be able to use your mobile phone around Europe for free, so you have to adapt it. And in my opinion, it should be something like this, a Commission or one. European policymakers in order to
I agree with that. So in the part of the national component in regulatory, because although we have all the EU laws and everything, when it comes to the transposition of the law to the different countries, it is a whole world. I mean, for example, in Spain, with all the transposition of self-consumption, energy communities and everything, they are not changing the regulation maybe at the speed that it is needed or that the technology can provide. So yes, we have to deal also with this. It's not just focus on the European side, it's at national level. Every company has to check how to do this and how try to push the policymakers of that country to make it happen.
Maybe I have the same feeling because in the international perspective or the EU level, there is a policy, but because of the principle of subsidiarity, the member states make their own transpositions, which are many times very, very diverse. So I have an example in my mind right now because we try to develop regional connectors to fetch data from data access providers from different member states. The problem was very, very different because the technology is, or technological breakthrough was not very challenging, but what was more challenging is because the fragmentation in the data access was very different. For example, in Spain, there is one central database which provides data. But in case of Austria, there are different DSOs who know the data. But still there is a platform through which you can fetch the data. But in case of France, this is the DSO which is operating the data or saving the data where we so because for example, we get the data from Enedis. Yes, but yeah. So, but in case of Spain, we get the data from database or EnergyNet in or Denmark, like the FinGrid in Finland and so on. But this fragmentation poses different challenges because sometimes the permission administrator is someone else, not just the DSO, but a different permission administrator is there. But also not just the permission and data access, but rather also the type of data what we are getting. So sometimes the data granularity was 15 minutes, sometimes it was 1 hour, sometimes it was once in a day or something. And additionally, also for how long you can access the data. For in some countries, it was just 3 years in future you can access the data, but in some countries it was indefinite. So because to be specific, 9999 plus years. So this poses very different challenges, and not just the technological breakthrough, but rather to collect the information how things work in different countries, and then to develop solutions to this. Because if you have a country where you have to fetch data from a DSO, you need to develop different interfaces to fetch the data from different DSOs within a country. For example, in Austria, there are more than 140 DSOs. So this could be a problem when the national transpositions are very diverse. That's my opinion.
Okay. So I also have an opinion about this. we're running out of time. I can ask Patricia if you want to say some last words, and afterward we have a branch all together. That we can
It's in the first floor.
Yeah, it's in the first floor.
Maybe I would like to thank everybody. I think because it's always enlightening to listen to the project, and mostly it is very nice now to see that everything is it's also in the end interconnected. I know that it's very easy to do, and we are usually used to get many bumps, yes, regarding with the commission work. Many of us, in fact, we joined the commission after working in companies or universities like you are doing now. So we did 2 lives. But what I think it is extremely good now it is that even if the energy and the digital sectors are still, and again, I hope that Michelle will not be upset with me running at different speeds. Yes, for many years now, it is a discussion. It is not we understand that the regulation, again, I'm coming from DigiConnect, so I'm not part of the DGNL, which is regulating the sector. We understand that sometimes things are heavy, but these are coming also as following feedback from, let's say, from all of you, from the real people, yes, what the system needs. What it will be important, I think, that how progress was done and continues to be done is by discussing between yourselves. Because if you consider that from the technical point of view, something is possible, and you can convince also the system operators, yes, in the case of energy, which are the ones who are managing the grid and then push responsibility for things. I assume that small things can be put together. We need to have a data space. We need to have a data space which we need to have data from the DSOs, from the service provider aggregators. We need to build trust. This is probably the most important thing. We have all this technological capability in Europe. On the other hand, we also see that there are the big American companies and some other big tech companies coming to Europe and entering the business of the system operators. So try to see, yes, we have regulation. It's very lengthy to change the regulation, but before saying it is very complicated, try to propose some technical solutions and to convince the operators that things can be changed. And I'm sure that slowly, things will be changed. And the projects are going, many of them to finish soon. It will be very interesting to hear how the work, the valuable of the work of the project is accepted, at least a tiny bit, by the system operators, by the aggregators, so by the people who contribute to, in the end, delivering as the energy. And we are looking forward now because it is the preparation of the next program period. We do not know very well how the programs will be structured, but what we know for sure now is that it will be an R&I program as usual, and it will be also a big component for deployment because we need to ensure the competitive to support the European companies to stay to maintain their competitiveness. So it will be this component in what will come. If you have ideas, if you have suggestions, if you would like to feel that something is needed, please try. We are very much willing to listen to you because you are the people who are implementing things. And then with the legislation, I think that slowly things can be changed. At this time, very happy that I did not hear today that we do not have standards because we saw the standard, let's say, standards with which the projects were ending their presentation some time ago. We are lacking standards. And at least we are progressing. Yes, we do not have this. Maybe interoperability is not perfect, but again, it's very nice to hear you, and we are very much here to listen to you, mostly us, the project officers, because this is the entry level and the contact that you can have with us, and we are very happy to listen to you if you have suggestions.
Thank you, Patricia, thank you all.